Welcome back from break all. Thank you for the wonderful questions that have been flowing through the chat. And thank you, of course, to Health and Life Sciences Cloud and Data Zone, Todd Morris, our principal solution architect, for addressing many of these questions today. You will have more time with him, as well as another colleague of ours, Eric Howard, later this afternoon in our 2:30 Q&A session. So encourage you to keep the questions coming in the chat now. And for questions that require engagement and conversation, we're going to open it up to a discussion forum end of day by way of reminder. So Todd, excited to turn it over to you to discuss our larger platform here at Microsoft and how Azure API for FHIR helps enable the ingestion and connection of data across our stack end to end. So Todd, whenever you are ready, we will turn fully back over to you. And I think you're on
Well,
mute.
yep,
We have, yeah.
yeah, hopefully I just fixed that. Greetings, everyone. Before we go into, actually, I need to probably do a take control. Can everyone still see the slides? Dana, Kim, is that working?
Yes, you have control.
Okay. Quickly, before I go into a discussion about the reference architecture, there were a few questions in the chat that I just wanted to quickly touch on. The first one really was related to performance and the ability to move significant amounts of data from an external data store into API for FHIR. Until such a time as we can actually rewrite the rules of physics, we're going to have some physical limitations that we need to deal with when it comes to moving data. Additionally, there are coding practices that we try to highlight in some of our OSS code, in particular the bulk loader, to demonstrate how to do back off timers and how to really drive your code to the point where you're getting the maximum performance from the system. Once your code has been optimized, obviously the next step is to go in and look at the API for FHIR infrastructure and make changes, whether that be on the database backend or to the components that are actually front-ending the service to make sure that they've scaled out to reach your kind of maximum throughput. What we've seen and what we've had to do with a few customers that had significant amounts of data is we've actually spent some time looking at their load patterns, looking at the code that they're using to load data. And then we've worked with them as well as had them open up an incident ticket where we work with our support teams in the event that we needed to make some changes to the infrastructure to truly get them to the point where they could ingest data at a rate that was aligned with the business outcomes and their specific requirements. So that's just kind of the nature of the beast. There was another question specifically related to using FHIR as a data store and would organizations have to copy all of their data into FHIR. We've seen a couple of different patterns. The primary pattern is for organizations to extract data and to load it into a FHIR data store, whether that be HL7 format data or whatever format it happened to be in. Additionally, we've seen organizations that implement a facade approach where they actually build FHIR compliant APIs that sit on top of existing data stores and data services. And we've seen hybrid approaches as well. So it all depends upon the use case. All of those options are valid, and we've seen all of them. With that said, I'd like to just go ahead and jump into our reference architecture here and just kind of walk through that process. Fundamentally, the reference architectures were created to provide our partners and our customers blueprints that show how you can connect the various components that make up Microsoft's healthcare services and bring them together in order to support your specific business requirements and needs. We've published a collection of these out on GitHub, and that link will actually be provided and should be available to you in the Microsoft Health Architectures GitHub website. One of the things that we primarily talk about is we ultimately have a data source, and that data source could be virtually anything. It could be an external FHIR server. It could be a FHIR server, for example, that is part of an EHR. It could be imaging data that's stored in a PAC system. It could be data from a billing system. Then we take that data and we move it through an ingestion pipeline where that data can be transformed, validated, any other operations that might be required in order to prepare that data for ultimate transformation and landing into the FHIR service. And so we have that persist layer where we have our FHIR data store. You'll see in our reference architecture that we also call out, we have a DICOM data store. And over time, you'll see additional services that will show up in our persistence layer as part of our overall healthcare solutions. Moving along, one of the things that you will see, and we've talked about this casually, is the Microsoft Cloud for Healthcare. And we've talked about a sync agent, which actually allows us to go ahead and move data from the FHIR data store into Dataverse and into the Dynamics environment so that this way it can be fully utilized in the Microsoft Cloud for Health solution. Furthermore, we have other tools and capabilities that allow us to move data from a FHIR data repository into platforms that are more suitable for large-scale machine learning and data analytics. And on the far right-hand side of the diagram, obviously we have presentation layers that will allow you to interact with your data, display reports. You can actually send information back into an EHR or some other data source destination. One of the things that the team has worked on in order to make life a bit easier for our partners and customers that are using the service is we've actually created a set of FHIR Workbench tools. At the end of the day, we really are trying to deliver on a goal of giving you a single button click that will actually go ahead and deploy all of the infrastructure that you need in order to be productive, whether that be building new applications or going off and doing data analysis and performing data analytics, or to start a machine learning project or whatever it might be. So we've built a set of tools in the form of Bicep scripts and Azure Resource Manager templates that will deploy all of the Microsoft building blocks so that this way you can actually go ahead and get started. Everything that's part of the API for FHIR and Azure Healthcare APIs infrastructure. I'll go ahead and talk a little bit about some of the features and capabilities that exist in the API for FHIR. One of the capabilities that exists is the Azure FHIR Converter. This allows you to take HL7 messages or CCDA messages, pass them along to the FHIR service, and actually have those messages transformed into proper FHIR messages. I want to point out one thing is the FHIR Converter does not directly persist the converted messages. So you would call the FHIR Converter with your HL7 message and specifically the conversion operations that you want to have happen on that HL7 message. And then we will return to you a formatted FHIR message. This gives you the ability to go ahead and perform any additional data manipulation or any other validation and additional activities that you might want to perform prior to persisting that data in the FHIR store. And then ultimately you could post that data to the API for FHIR store. Another capability that's built into the Azure Healthcare APIs is the ability to export data from the FHIR store. Many customers want to actually export anonymized data such that this way they can pass it off to data scientists and perform additional analytics and machine learning operations. So we've got a capability built into API for FHIR where you can actually call $export, provide some query parameters, and then that data will be written out to Azure storage. And at that point in time, you can pick it up with your favorite data analytics tools, whether that be Azure Synapse, Databricks, or if you just wanted to work on the data using Python, any other scripts that you might want. Additionally, we support de-identification. We have a set of de-identification models that are built into the tool, and you can extend those to enhance the way the data is de-identified to comply with your organization's or your customer specific data classification and data de-identification rules. Quickly moving on to another component that our team has built. The component, we refer to it as FHIR Proxy. So if we take a quarter of a step back and just look holistically, the FHIR standard, the FHIR specification defines a rich, robust set of data interactions and data formats, data models that we can use to manage healthcare data. At times, you'll have cases where you need to manipulate your FHIR data in a fashion that may not be 100% aligned with the specification or the standard. Or in some cases, you may have features or capabilities that might exist in a future rev of a FHIR standard or may not be implemented in API for FHIR. And using that as a backdrop, that's part of the reason why we created FHIR Proxy. This gives us a front end to the FHIR service and allows us to introduce custom operations so that this way we can extend the capabilities of the FHIR service as needed and enhance capabilities that may not be up to spec or up to a specific requirements. So what you'll have happen is the data will come from a source. It will reach the FHIR Proxy. FHIR Proxy will perform whatever custom operations that have been defined that Microsoft has developed or custom operations that you have developed in order to solve a specific business use case. And then you can pass that data along to FHIR for ultimate storage. Again, just want to go back and continue to follow up on what we've been saying about Proxy. It gives us the ability to inspect that data, enrich the data, perform alerts, do things that you might need to do. We can actually trigger custom events before data is actually sent along to the FHIR server. And we respect all of your PHI rules and boundaries. Digging down a little bit deeper for FHIR Proxy to talk a little bit about how it's implemented. FHIR Proxy is actually implemented as a collection of Azure functions that are grouped together. They're running in an app service plan, and we support the ability to do pre-processing as well as post-processing. And that's just really the way the proxy service works. In addition, we'll talk about this later on today. The proxy service gives us the ability to introduce additional authentication, authorization, and consent functions that are not 100% present in the API for FHIR service. As a middleman, we actually see all of the data and we can actually take some additional operations to implement custom data filtering or custom access control rules. Furthermore, if you wanted to do things specific to a version of FHIR, R2 versus R4, we give you the ability to implement those capabilities and, for example, route requests to specific FHIR servers on the back end. A common question that I receive from customers and partners is, why did you build FHIR Proxy? Why isn't everything just done using the Azure Service API management? There are a couple of reasons for that. I'll go with the simple reason first, is FHIR Proxy is really a low-cost, very, very focused solution that's pretty easy to deploy and for our customers to go ahead and implement and begin to use quickly. Typically, you require some additional skills. There are obviously additional costs that go along with implementing a full feature API management solution. However, we support that as well. One of the things that myself and our team is working on is taking some of the features and capabilities that we developed for the initial version of FHIR Proxy and bringing those into policies and custom operations that are tightly integrated with API management. One of the additional things that customers have asked for and why we're moving forward with API management is the simple fact that FHIR Proxy, while the underlying services, API, Azure Functions, and Azure Application Services are fully embraced by the Microsoft platform, some of the content routing capabilities are really covered by the OSS nature of FHIR Proxy. By moving those functions into API management, customers can also take advantage of all of the work that Microsoft has done literally with respect to API management. There's an additional set of capabilities that come along with that, which simplify life and allows you to take advantage of Microsoft certifications and enhancements that are constantly occurring in API management. I'm going to move on and talk about another component. As we mentioned, FHIR Proxy is a piece of middleware that stands between external systems and the API for FHIR to implement custom operations. We've also built a tool that we call FHIR CDS Sync. That tool allows us to sync data that lives in a FHIR data store with, excuse me, Dataverse and our Dynamics platform. So as data moves through FHIR Proxy looks at that data, will go ahead and perform the appropriate data transformations and operations in order to land that data in the common data model in Dataverse, so that this way it immediately becomes available to folks that are using the Dynamics platform in the Microsoft Cloud for Health. Typically, the latency involved between the message arriving at the FHIR Proxy and that data showing up in Dataverse is roughly on the order of half a second. So in less than a second, information that is passed via FHIR will show up in your Microsoft Cloud for Health. And this is actually a two-way sync. We've got rules in place for data mapping as well as sending data back into the FHIR environment. And as Data mentioned, we won't do hands-on, but if you've got use cases for this, we can absolutely sync you up with our fast track team and walk you through the details of how to deploy, how to configure this, and get you up to speed so that this way you can be productive with the CDS Sync agent and the Microsoft Cloud for Health platform. Just moving on a little bit, this just drives in a bit deeper. And it really just talks about what I said at a finer level of detail. Healthcare data that is processed via FHIR Proxy or out of healthcare APIs is then picked up and mapped to Dataverse resources and Dataverse elements. And then there's a sync process so that every time a new event occurs and as data is changed, we move data bidirectionally back and forth between the two environments. As I mentioned before, we talked about FHIR Workbench. That's a collection of tools that we have to enable our partners and customers to deploy infrastructure. A precursor to FHIR Workbench is actually a repo that we call FHIR Starter. And that is a repo, again, that makes it relatively easy to go ahead and to deploy all of the infrastructure that's required to begin working with Azure Healthcare APIs, API for FHIR, to go ahead and build specific applications and services that you might need. The FHIR Starter environment will go ahead and deploy API for FHIR. It will help you set up all of the Azure Active Directory authentication and credentials that you might need in order to bring all of the services together, so that this way you can actually go ahead and start building products and solutions. In addition to just deploying infrastructure components, we're trying to make life a little bit easier for our partners and developers. So we have components in the FHIR Starter kit that actually will go ahead and generate environment files that can be imported in the Postman. Again, the goal is to help organizations and teams go from I need to do something to I can actually start working and solving problems as rapidly as possible. FHIR Proxy is one of the components that we just talked about, and we actually have a full suite of deployment scripts that enable you to deploy FHIR Proxy quickly and efficiently. Again, as part of the deployment process, we actually create files that will enable you to go ahead and do all of the authentication work that's necessary in order to be productive with FHIR Proxy as rapidly as possible. One other thing that I just want to mention about FHIR Proxy, that is an open source project. So you're free to go look at all of the code. You're able to look at the modules, post-processing, pre-processing modules. And for developers, folks that actually like to write C# code, you're free to go in and modify or enhance those as necessary in order to solve your specific problems. We have another module a little later on this afternoon. I'll go into this in greater detail. FHIR Proxy as well as API for FHIR support common OAuth authentication. So there are a few steps that you need to do in order to effectively implement that. You'll create what are known as application registrations. You'll create secure client credentials. We'll also leverage managed service identity where applicable and where appropriate to simplify the credential management problem. Obviously, we want to take advantage and really minimize the exposure of credentials where we store them and how we store them. We fully leverage and support Azure Key Vault for managing and storing credentials in those cases where we actually need to store them. As we talked about at the beginning of this session, the ability to take large sets of data, or any data for that matter, and to bulk load or batch load it into the FHIR service. We've actually got a tool called FHIR Loader that will actually take JSON, NDJSON format files, bring that data in, and actually load it into API for FHIR. Basically, the way it works is once you've deployed the FHIR Loader infrastructure, you'll have an Azure storage account that you can go ahead and upload your files to. Then the FHIR Loader will actually monitor that storage account. It will look for files as they're uploaded, and that will trigger the process for the FHIR Loader to read that file in, perform some basic validation steps, and then push that data into the API for FHIR. I want to go ahead quickly and move into a little bit of solutions. We've talked about the tech, the individual components that come together. Really want to step back a notch and really look at some of the common scenarios that we've seen with our customers and problems that they're trying to solve. And I'll talk about that for a minute. But before I jump into that, are there any questions? Just trying to take a quick look at chat. I don't see anything. All right. So we'll just kind of go ahead and we'll talk about a few common use cases and scenarios.
Hey Todd,
I
I
see.
had a question.
Sure.
Oh, sorry, I was on mute. Basically, in previously that you talked about Azure FHIR Workbench. Is that Workbench is something as a repository of all the FHIR related assets to deploy for the customer? Is that right?
Correct. So today, that is a set of bicep, arm, bash scripts and templates that allow you to deploy the infrastructure and services needed to go ahead and build healthcare applications. Additionally, and over time, it will also include things like sample security reports. So now that I've got my API for FHIR environment all set up and I've got logging data to Azure Log Analytics, how do I quickly query to understand who might have accessed a bit of data? Those are the things that we're all adding into the FHIR Workbench. Again, it's all about helping make folks productive as rapidly and as quickly as possible.
Okay.
Going back to kind of our solutions focus, again, this is aligned with some of the things that Dana talked about earlier. This is really about real world data. How do I collect that data? How do I bring it in to an environment where we can actually go ahead and turn that into evidence and ultimately drive actions? So this use case is I need to build a patient outreach system. This is a common element or common request that we see from customers. How do I get data from customers so that this way I can actually provide meaningful insight and actionable information? As we walk through the process, the Chief Quality Officer obviously has identified a set of requirements, a need to read patient rounding surveys and responses, and then to actually turn that into actionable information. You have Henry, who's a data engineer, who's really interested in getting that data and how do I turn that into some bit of information or some bit of data that I can use with my teams and with our organizations, our outreach teams to go ahead and impact our customers. If you go back and we take a look at the building blocks, we've got a number of different ways to get data in. We could get data in via an application that's running on iOS or Android, a Smart on FHIR app. We can bring data in using a number of other tools, but the things that are most important for this specific use case are really going to be once we get the data from our mobile app, how do I map that to elements that exist in Dataverse? And so we've got a FHIR data mapping tool that's going to help us take the data as it lands in FHIR and map it into Dataverse, Dynamics, Cloud for Health. We've got the Azure API for FHIR components. Again, that's a way to bring that data in pretty easily in a format that our partners and our customers and patients around the world are accustomed to using. They're getting real used to. I bring up my mobile app and I've got an application that allows me to respond to a survey or integration with a patient portal. Another component that plays into this is obviously the FHIR proxy and the sync agent. That's how I'm going to synchronize the data. And then I can bring that data into Microsoft Cloud for Health with our patient outreach module and Dynamics 365 to actually drive workflows that support the objectives of the organization. On top of all of this, we've got our standard security capabilities. I've got Azure Active Directory for identity management. I've got Azure Key Vault for secret management. From an operations perspective, I've got application insights, log analytics. Those are tools that we can use to understand the performance, behaviors, and characteristics of the system while it's operating and be able to troubleshoot and do that end-to-end operational support for the system. And then in this case, we're going to leverage the FHIR sync agent, which is going to be our FHIR CDS sync agent, which connects the data from FHIR to Dataverse. This is just a graphical representation of what we talked about. Really to talk about kind of the sync components. On the far left-hand side, which is not depicted, I might have a Smarter FHIR app. That data will move into Azure API for FHIR and or FHIR Proxy. Then from FHIR Proxy, we'll pass that through Service Bus, FHIR Sync Agent, and then we'll move that data into Dataverse, so that this way we can actually drive the patient outreach app. Again, this is just kind of the summary. That's the problem that we solved. How do I bring this data in from my patients? How do I analyze it? How do I get that to a person on my hospital operations staff and an outreach agent, a nurse, a practitioner, make sure they have the right information and they can actually effectively interact with that patient.
Todd, are you available for a question? We have a guest, their hand raised.
Sure.
Hi, Todd. So on a couple of slides prior to this, you had a patient consent with Azure Active Directory. Can you perhaps just elaborate on what that capability is? We had a consent capability there.
This afternoon, we actually have another session where we'll talk about authentication, authorization, and consent. But what I'll do is I'll do a quick pause right here for now. One of the capabilities that we have built into FHIR Proxy, we've got sample code out there such that this way, if a consent record resource is posted to the FHIR server, we will respect that resource so that as data is moving around, we'll enforce the rules of that particular consent resource. Typically, and what we'll demonstrate during the hack as well tomorrow is an opt-out consent resource where you can create that resource, post it to the FHIR server, and then Proxy will actually go ahead and whether that be for an organization or an individual, whether that be a provider, you can actually go ahead and implement that consent opt-out capability. But that's really what that refers to.
Thank you.
There's no secret sauce or magic in that. That is just really referring to standard FHIR consent resource processing. One of the things that would happen in this patient outreach process is once I collect the data, what else can I learn? What other things can I do? How can I use that to influence the way I operate the hospital or the way I operate my practice in order to deliver better care, in order to improve margins, in order to maximize, our revenue operations. So you'll have data sets that you can bring back and do analytics on, and you can push additional data in the FHIR. This particular slide focuses on the outreach, the contact portion of it, but that's just one element of this kind of overall solution. Looking at it from a different perspective, especially if you're an application developer or a data engineer, and this is another element where we get into data mapping and we get into the FHIR sync agent. So as a data engineer, I'm going to be really interested in, now that I have a suitable reference, the FHIR standardized data, I need to map that to Dataverse elements. How can I influence that mapping? How can I send data back? There are things that we may have customized in Microsoft Cloud for Health, and I need to push that data, for example, back into API for FHIR such that my mobile app can do something with it. You've got the ability to do those things with extensions. Again, we highly encourage you to minimize the use of extensions. We've seen historically that can create interoperability problems, and it can create challenges with maintenance for systems over longer periods of time. But the API for FHIR and the Seek agent allow you to go in and have fine-grained control over that data mapping and the ability to extend those data sets. This is just another example of that actually drives a little bit further into what I've been talking about, is how you actually go ahead and take a specific FHIR resource, a specific FHIR entity or element, and then actually go through that process of writing the rules in the sync agent to map that to Dataverse attributes. We fully support the data mapping exercise. And as a matter of fact, the vast majority of time that's spent on FHIR to Microsoft Cloud for Health work is spent in doing that data mapping. We're pretty much so at the end of the slides. Again, we'll just do a quick recap. The FHIR specification provides a standard and a robust method to define health data, and it supports interoperability. It was created to support interoperability. The FHIR specification defines the methods that data can be exchanged. How do I send data from point A to point B? What are the rules for that? It gives you the ability to validate the data that's incoming to your system so that this way you can say, for example, I expect or require that gender be filled in. You can actually reject a request to post a patient record if gender isn't filled in or isn't compliant with a particular format or standard that you have. Azure API for FHIR is our GA service. We also talked about healthcare APIs, which is our soon-to-be GA service, which brings in not only the FHIR services, but allows you to extend that with DICOM and medical device integrations and other healthcare services over time. I'm going to pause now when I actually see a hand raised.
Yes, hello. I've got a question on the sync agent.
Yes.
Are there limitations around what resources the sync agent supports, or is it extensible? Like, there's a bunch of commonly used FHIR resources, but then there's a bunch like, say, task that is not used.
Yep, the sync agent is extensible. There are a couple of things that I just want to point out. In an engagement, we can actually talk through how you would extend it and work with the teams that actually can guide you through that process. Behind the scenes, as we move forward with Azure Healthcare APIs, the Dynamics team is actually taking greater and greater ownership of the sync agent. They recognize that it would be beneficial to all of our customers to have deeper and deeper integration. So the look and feel of that interface is likely to change over time, but you can absolutely extend it to go out and bring data in from resources that might not be as commonly used. If you go back and look at some of the slides where we talked about the architecture, we're leveraging FHIR Proxy, we're leveraging events from the FHIR service, and when those events trigger, we'll actually take the FHIR resource and actually go through and do that mapping, data mapping.
Cool, thank you.
Does that answer your question?
Yeah, thanks.
Dana, any additional comments?
Thank you, everybody. Our first module is complete, Health Data and FHIR. I know there'll be more questions as we move through the day. We'll give everybody a break and we will come back at the top of the hour again. So that is going to be 11 o'clock Pacific time. Thank you, Todd. Awesome presentation walking through our capabilities, the broader landscape of health architectures at Microsoft, and how to connect data to the Microsoft Cloud for Health specifically. So thank you so much. And thank you, everybody, our partners, our Microsoft colleagues for being here today. We will see you in about 20 minutes. Appreciate it.